definitely. Thank you so much. I'm hitting the record button right now, guys. So thank you very much for bringing that up, Bevla. That was my bad. I thought about it earlier and I was going to hit it and I forgot. So Kyla has number 13. So Kyla, before I get to number 13, did anybody have any questions before number 13? Guys, I just want to kind of go in order as I'm going down, like 1 through 13 or whatever. If anybody has any questions about any of those, please let me know. And this way we're not kind of jumping back and forth, but I'm definitely going to get to number 13. I got number 4. So let's take a look at number 4. Okay, so I'm just going to zoom in a little bit here, y'all, so we can see this a little bit better. I want to make sure that you guys can see this as well. It looks like you can. Okay, so it says a company is conducting a survey to determine how prepared people are for a long-term power outage, natural disaster, or terrorist attack. The frequency distribution on the right shows the results. Use the table to answer the following question. And the question says, what is the probability that the next person surveyed is very prepared? Okay, so let me get my pen going here. There we go. Okay, so guys, the first thing I need to do, I need to find the sum of my frequencies here. So what I'm going to do is I'm just going to grab the calculator. I just got a calculator right here in front of me, and I'm going to start adding these numbers up. So I got 2. Now, guys, one thing I want to mention again. So for instance, if this was a problem on your test, the only thing that would change would be the numbers, right? But the process would still be the same. Okay, so I'm taking 266, 946, 542, and what else? 316 and 61. Okay, so what I'm coming up with is my total is, 2131. And the question says the probability that the next person surveyed is very prepared. So very prepared is right here. So it's going to be 266 out of my 2131. And what I'm going to do here, guys, is I'm just going to take my calculator, 266 divided by 2131. And we're going to round it to 3 decimal places because that's what it says. And I'm coming up with 0.125. So let's see, 0.125. There we go. Okay, so hold on real quick, guys. Somebody's asking how do we get into the session. So let me tell everybody. Let's see. So also on Bronco. All right. So anyway, I'm sorry. I'm back, guys. So for number 4, I'm hoping that made sense. Guys, before I get to number 13, any other questions before I get to 13? 7 and 8, of course. Let's take a look at 7 and 8. 7 and 8, good. I'm seeing number 8 quite a bit, so let's get to these. Okie dokie. So, yeah, apparently I had already done number 8, so it printed out, but it's okay. We'll figure it out together. Don't worry, guys. Okay, so it says number 7, an environmental agency is analyzing water samples from 75 lakes for pollution. 5 of the lakes have dangerously high levels of dioxin. 6 lakes are randomly selected from the sample. Using technology, how many ways could 1 polluted lake and 5 non-polluted lakes be chosen? Okay, so let's take a look here. We know we have a total of 75 lakes. So I'm just going to kind of make this like this. So the total I have is 75, right? And we know that 5 of those lakes are polluted, okay? So 5 are polluted. So that means 70 of them are not polluted, right? And we're going to choose a total of 6 lakes. Okay, we're going to pick 6. And it says, how many ways could 1 polluted lake and 5 non-polluted lakes be chosen? So we're going to pick a total of 6, and we want 5 of them to not be polluted and 1 of them to be polluted. Okay, so the way we're going to do this, guys, is since I want 1 of them being polluted and there's 5 polluted total, I'm going to go 5, choose 1. Okay. And then there are 70 that are not polluted. And we want to choose 5 of those so that we have 5 not polluted. So the idea here, guys, is I'm going to use my calculator. The one thing I want to emphasize here is that, let me get my pen going, sometimes it freezes. The 5 and the 70, when I add them together, gives me my 75, right? That's how many we have total. The 1 and the 5, when I add them together, gives me my 6, okay? So guys, I'm going to share my calculator so that you guys can see the process and how I'm going to do this. So let me stop sharing this and let me get my calculator for you all so you can see how I'm going to do this. There we go. So guys, I'm using my calculator here because this is what I have on this computer that the school issued to me. But the one thing I want to emphasize is when you're doing this, you're going to do this exactly the same way if you're using that calculator app, okay? So what I'm going to do first, I'm going to go to math, and I want to get to the probability. So I'm going to do my left arrow once. Wait, sorry. Let me come back and see to look at my numbers again. Okay, so I have 5, choose 1, and 70, choose 5. Okay, so sorry about that, guys. Let me do it exactly as I wrote it out. So I'm going to put parentheses, 5, math, probability. We're going to go down to number 3. We're going to choose 1. Close off, times 70, math, PRB, and I'm going to choose 5 from here. And I'm going to hit enter, and the number that I'm coming up with is, I'm going to write some stuff down here. So 605, 15070. Okay, so let me stop sharing this and let me come back to my notes. There we go. And so the answer that we came up with, and guys, one thing I will say, they can be a little confusing because it says like round to 4 decimal places. We don't have any decimal places here, right? So that part sometimes seems a little confusing. 1507, right? Okay, now we're going to do number 8. Number 8 is going to be done very, very similar, okay? So number 8 says, a shipment of 10 microwave ovens contains 3 defective units. So guys, just like I did before, remember what we have? We have a total of 10, and 3 of them are defective, so 7 are not defective, okay? And it says a restaurant is going to buy 4 of the units. What's the probability of buying at least 3 non-defective units? Okay, since we're doing probability, we are going to come up with a fraction or decimal, okay, because this is a probability problem. So it's usually, I say it's easier for me to do my denominator. Okay, so how many microwaves do we have total? We have a total of 10, and we're going to buy a total of 4. So my denominator is going to look like this, 10 choose 4. Okay. Now my numerator, the way I'm going to do my numerator, guys, is we want to have, what's the probability of buying at least 3 non-defective units, okay? So what does that mean? That means that out of the 7 we have, we can choose 3 of them that are not defective, and out of the 3 defective, we can choose 1 of those being defective. So this is a case where we have 3 not defective and 1 defective. The other possibility we could have is we could have, out of those 7 that are not defective, we could choose all 4 of them from there, and then out of the 3 that are defective, we're going to choose any, okay? So guys, I'm going to write this on my paper exactly the way I would do this on my calculator. So I'm using the red here to kind of let you know how I'm going to do this out. Okay, so I'm going to put two sets of parentheses. So the first one, and then my 7 choose 3, and my 3 choose 1, plus, and then my 7 choose 4, and my 3 choose 0. Close that off, and divide everything by 10 choose 4, and we should come up with this answer right here. So let me stop sharing this, and let me pull up my calculator for you guys so you can see it again. Here we go. Okay, and so let's see. Let me clear this. So I'm going to put two sets of parentheses, and I had 7 math, oops, PRB, choosing 3, okay. Close my parentheses, open another set, 3 math, PRB, then I choose 1, okay. And then plus, I had parentheses, 7 math, PRB, choose 4, and 3 math, PRB, choose 0, close that off, and I had to close another set off, and then divided by, and I'm going to go ahead and put these in, well, I don't need to put these in, we should be okay. 10 math, PRB, choose 4, and now when I hit enter, there's our answer. 0.666, right? And that's me around the 3 decimal places. And so guys, let me stop sharing this screen here. And let me come back to my notes so we can see it. And let's see, where are we? Here we are. And if you notice, let's see, that's exactly the answer that we came up with, right? So, question, does that answer y'all's question for 7 and 8? Like, do y'all feel better on knowing how to do problems like 7 and 8? So if the numbers change, do you feel like you could do it? Do you feel like you could do 7 and 8 if the numbers changed? Yeah, good, good, good. So guys, before I go on, again, one thing I want to emphasize, so let me get my pen here. Okay, so remember, the 7 and the 3, those have to add up to 10, and then the 3 and the 1 have to add up to 4, right? And the same thing happens here. The 7 and the 3 add up to 10, and the 4 and the 0 have to add up to 4, right? So that's just something that you can use, you know, when you're doing these problems, like to make sure, am I coming up with the right numbers, right? Am I getting the right answers here? Okay, so I think the next question we had was number 13. Before I get to 13, did anybody have any questions before I get to number 13? Okie dokie, so let's take a look at number 13. Okay, excellent question. I'm glad you asked this one here. And it says 40% of US adults have very little confidence in newspapers. You randomly select 10 adults. Find the probability that the number of adults who have very little confidence in newspapers is exactly 5, at least 6, less than 4. Okay, so let's do part 8. Let me get my pen. Sometimes it freezes, guys, so if you hear a little tap, that's me hitting my pen. We're trying to find exactly 5, okay? So first thing we know is my n. The number of adults that we've selected is 10, right? And then the next thing we know is our p. Our p is what's the percent, or what's the probability that they have little confidence in newspapers, and it's 41%. So it's a 0.41, okay? And my x number here is 5, because I'm saying out of those 10, excuse me, what's the probability that exactly 5 have little confidence in the newspaper? Okay, so guys, this is a binomial distribution. And because this is a binomial distribution, oops, I'm going to use something called Binomial Pdf. Okay, and I'm going to explain what this means. Binomial Pdf. And let's see. Let me get my calculator real quick. Because, let me see. Bars. Yeah. And the way I'm going to do this is it's going to ask me for three numbers, my n, my p, and my x. So guys, if those of you who are using the calculator app, I'm going to show you how we're going to do this. But if you go on your calculator, if you go second, and then vars, and then Binomial Pdf is going to be choice A. And if you look at it on your calculator app, unfortunately, guys, like on my calculator, it doesn't tell me that. But I have like the number of trials and then P and X. So that's just what my number of trials, my P and my X are. Okay. So what I'm going to do here, I'm going to go Binomial Pdf, and I'm just going to fill in my blanks. So I'm going to go 10, comma 0.41, comma 5. Okay. And this is me finding the probability that exactly 5 have low confidence. So let me stop sharing this. And again, guys, on my calculator, I'm going to go second vars. I'm going to choose A, and then I'm going to type in this piece right here. So let me come back here, get the calculator going so you can see it. And it's going to work the same way on your calculator app, okay? So let me clear this out. So I'm going to go second button, and then vars. I'm going to scroll down till I find Binomial Pdf. And here it is. It's choice 0 on my calculator. We said our n was 10, comma, my probability was 0.41, comma, and my x number was 5. And so what I'm coming up with here is 0.2087. So let me stop sharing this and come back to my notes. And 0.2087, 0.20, so be 2.209 if I'm going to go to 3 decimal places. Okay. All right. So now let me do part B. Part B says, what's the probability that at least 6? So here we have the at least 6 part. Okay. So one thing I want to mention, when it says the probability that x is bigger than or equal to 6, I want us to understand what that means. Okay. It means that 6 people, or 7 people, or 8 people, or 9 people, or all 10 have this little confidence in these papers, okay? Now, guys, remember how many people we were serving? We were serving 10 people, right? So the idea is, if I were to add, I want you to think about this for a minute, okay? Okay, I want you to think about this for a minute. If I were to add from 0 to 1 all the way up to 10, because I'm dealing with probabilities, this would actually be equal to 1, right? So one thing I can do is I can say, if I'm trying to find this value right here, one way I can do that is I can say, let me take 1 minus the probability of 0, of 1, all the way added up to 5, okay? Because if I have from 0 to 5, and if I add up all those numbers, and I subtract that from 1, that'll leave me with the 6 through 10, because there was 10 people here, right? So I can do this part right here, guys, using my calculator again. So I'm going to show you how I'm going to do that. I'm going to write 1 minus. Now I'm going to use something called the Binomial Cdf. Now what the CDF, what the C stands for, is cumulative. Cumulative meaning we're going to add from 0 to 1 to 2 to 3 to 4 all the way up to 5. Okay? So my n is still going to be 10. My percent or my p is still going to be 41. But now I'm going to go from 0 all the way up to 5. Okay? So I'm going to show you how I'm going to do this part on my calculator. I'm going to do it exactly the same way. Okay? Oops, sorry. So let me stop sharing this, and let me come back to my calculator. And so what I'm going to do, the first thing I'm going to do, guys, I'm going to go ahead and write, let's go second, and then vars. And I'm going to scroll down until I find Binomial Cdf, which is choice A here. Okay? And I'm going to hit enter, and I have 10, comma, 0.41, comma, 5. Okay? Enter. Okay, so I'm coming up with this part as my answer. I need to take 1 minus this. So on my calculator, I'm going to go 1 minus, if you look right here, right above my negative sign, it says ANS, and the way I can get to that is going second, and the negative sign, and it's going to say you're going to do 1 minus my answer. And so I'm coming up with 0.183. So 0.183 is going to be my answer here. So I'm going to stop sharing this piece here, okay? And I'm going to come back to my notes, and we're going to say we came up with, what was it? Here we go. We came up with 0.183. Okay? Now, part C. Part C says less than 4. And they read it out for me here. So let me explain what is that. Less than 4. Okay? If it's less than 4, that's the same thing as saying is it's going to be less than or equal to 3. Because 3 is smaller than 4, right? And any number smaller than that would be 2. So just so we understand, what does this part mean? This part means I'm going to take 0 and 1 and 2 and 3, and I'm going to add them all up. And since I'm adding them all up, this is when I can, again, use my binomial CDF with 10, 0.41, and since I'm stopping at 3, that's where I'm going to go. Okay, so the C again stands for cumulative. So I'm accumulating everything from 0 to 3, right? And so here, I'm going to stop sharing this part again, and I'm going to go back to my calculator one more time. And let me clear the screen for you guys. Okay, so I'm going to go second and then bars. I'm going to scroll down until I find binomial CDF. There we go. And we had 10, comma, 0.41, comma, and then we stopped at 3. And I'm coming up with 0.3575, so to 3 decimal places, 0.358. Okay, 0.358 will be my answer. So let me come back here. And so we said 0.358. Okay. So one thing I want to mention, y'all, is that when I did this part right here, I did this using my binomial CDF, but because I was not starting from 0, I was starting from 6 through 10, I said, well, let me find out what it is from 0 to 5, and then if I subtract that answer from 1, that's going to leave me with whatever's left over, meaning from 6 to 10, right? When we did part C, we wanted less than 4, so we were starting at 0 and going all the way up to 3, right? Because it has to be less than 4. So 3 is the first number that's less than 4, right? So from there, I could just use my binomial CDF. I didn't have to worry about the 1 part, okay? Guys, another way you could have done this, and it just takes a lot longer, is do you remember how we did the first part? We said Binomial Pdf, and we just put 5. We could have done that same process and done it for 6, done it for 7, done it for 8, done it for 9, done it for 10, and then added them all up, and we still would have come up with 0.183, right? And we could have done this part the same way too. We could have done binomial CDF, and we could have changed that 5 to a 0, and then a 1, and then a 2, and then a 3, and added up all those numbers, and we'd come up with a 0.358, right? But that's the nice thing about using that CDF, the cumulative, is that it does that adding for me, okay, without me having to do it every time. Good, good, good. Okay, so that was number 13. Let's see. Any other questions anybody has out of the review that y'all want to ask me about? Anything? Don't be shy. Number 31, definitely. We can get to number 31. Guys, before I get to 31, 15. Okay, let's do 15. Yes, we'll definitely get to 31. Don't worry, I won't forget. But Jasmine, please don't let me forget. Let's take a look at number 15, guys, and then we'll keep moving on. If y'all can think of any other questions in between that time slot, then definitely let me know. Okay. All right. So number 15 here says basketball player Chauncey Billups to the Detroit Pistons makes free throw shots 88% of the time. Find the probability that he misses the first shot and makes the second. Okay, so let's see. So guys, the first thing I'm going to do, I'm going to share with you guys my formula sheet, okay? So that, let's see, here we go. Okay, and yes, you guys can see this. Okay, so what we did right now, we used the Binomial Pdf for like the Binomial Cdf, right? Now, the next thing we have is something called the Poisson Distribution, and we have the geometric distribution. So the Poisson says the probability of exactly X occurrences in an interval. So what we mean by an interval, like it's an interval of length, it's an interval of time, something like that. The geometric distribution formula says probably the first success will occur is going to be on a certain trial. That means you're going to try something so many times and you're not going to succeed until the third attempt or the 8th attempt or the 15th attempt. So when I look at the problem for 15, let me pull that back up. And here we go. And it says, Chauncey Billups of the Detroit Pistons makes free throw shots 88% of the time. Find the probability that he misses the first one, but he makes the second. So his first free throw shot is going to be on the second attempt, okay? So guys, the first thing I'm going to do, I'm going to write down my formula, and I'm just going to pull it up from the formula sheet. Guys, the formula sheet is in the last announcement, the one that I sent to you all earlier today. So let me write down the formula, and it is P of X equals P times Q to the power X minus 1. P of X equals P times Q to the power X minus 1. Okay, so the first thing we got to figure out here is what's our probability P? Our probability P is the 0.88. That's the probability that he's going to make the free throw shot. So the probability that he's not going to make it would be 1 minus 0.88, which is a 0.12. Okay. And we're trying to figure out that he's going to, so it says he's going to miss the first shot, but he's going to make it on the second. So this means we're going to find P of 2. Okay. So guys, I'm just going to copy my formula here. So remember what we said our value of P was? It was 0.88. Okay, I'm going to put this in parentheses. Our Q value was a 0.12 to the power of X minus. So my power is going to be 2 minus 1. Okay? And so the way I'm going to do this on my calculator is I'm going to do it like this. Remember, 2 minus 1 is just 1. So on my calculator, y'all, I'm going to pull up my calculator so y'all can see it again. And here we go. Okay. So let me turn this on. Parentheses, 0.88, close it off, times 0.12. And my power in this case is the number 1, so I'm going to go ahead and put a 1. By the way, guys, 1, when you have a power of 1, it doesn't change anything. But I'm showing you that what happens instead of 1, if my power was 3 or my power was 7, this is in essence what we would do, okay? And then I'm going to hit enter, and I'm coming up with 0.1056, right? So let me stop sharing this, and let's come back to our problem here, 0.1056. And so we would say here, our choice is going to be C. Okay. All righty. Excellent questions. Very good, very good. So great questions, guys. I'm glad you're all asking this. I hope you're feeling a little confident as I'm going through these, with at least the idea of how would I approach this problem, okay? How would I approach this problem? So guys, I know the next one I have is 31. Do I have anything before number 31? Anything before 31 that anybody wants to ask me? Number 16, let's do number 16. Okay, so it says, a statistics professor finds that when he schedules an office hour at the 10:30 a.m. slot, an average of 3 students arrive. Okay, it says, use the Poisson distribution to find the probability that in a randomly selected office hour in the 10:30 a.m. time slot, exactly 1 student will arrive. Okay, so excellent question, Thomas. I'm glad you asked it. What I like about this question, it's telling me exactly what to do. It's telling me to use that Poisson distribution, okay? So guys, I'm gonna stop sharing this part and I'm gonna share the formula sheet again with you guys one more time. Let me pull it up. Where did I put it? Here we go. Okay, so right here in the middle is our Poisson distribution, and I have a little formula right here, and it says Poisson Pdf, and it has the mu and it has the x, okay? And it says this is the probability of exactly x occurrences in an interval, okay? So I'm going to stop sharing this. I'm going to come back and share my notes again, my review, I should say. Okay, so it says we're going to go Poisson Pdf, and it has 2 numbers. It has mu and it has x. So guys, the one thing I want to emphasize, remember, mu stands for my mean or my average, okay? And it tells me right here in this problem that we have an average of 3 students. So that's telling me that my average is 3. And it says, use the Poisson distribution to find the probability that in a randomly selected office hour, exactly 1 student, so my x is going to be equal to 1. So all I'm going to do here, y'all, is I'm going to go to Poisson Pdf. I'm going to put a 3 here and a 1 right there. And I'm going to show you all how I'm going to do this on my calculator. Guys, I'm going to do it just like I've been doing the others. So let me just kind of move over here. I'm going to go second and vars, and I'm going to look for that Poisson Pdf, okay? So let me stop sharing this, and let's come back over here. There's my calculator. Okay, and it should be coming up now. So let me clear the screen. So I said I'm going to go second, then I'm going to hit my vars button, and I'm going to scroll down until I see that Poisson Pdf. Okay, here we go, Poisson Pdf. Guys, there's 2. There's CDF and there's PDF. If I'm finding an individual value, I'm going to use PDF. If it told me, could you find, what's the probability that it's less than a certain number, then I would go with CDF, okay? So I'm going to enter this part in, and we said we're going to put 3, 1, and I'm going to hit enter right here, and I'm coming up with 0.14936. Okay, so 0.14936. So let me stop sharing this. Let's go back to the review. 0.14936. So my choice again is C. Okay, excellent, excellent. So guys, I know you didn't ask me, but number 17, I would do it exactly the same way. It's telling me use Poisson, right? Okay, so first thing is we're going to find our mu. We're going to find our average. My average is 4, right? Okay. And it says we're going to find the probability that we're going to get exactly 6 calls. So my x is equal to 6. So I would just go Poisson. Oops. Sorry about that. Go too fast. So I would go Poisson Pdf with 4 and 6. And then whatever I come up with on my calculator is going to be the number that I'm going to write. Okay. So guys, I can already tell you what answer it's not going to be. It's not going to be D, right? Because probability is always going to be a number between 0 and 1. Okay, so that's 725. I already know that's a blank. All right, good deal. Let's see. Any other questions before I get to number 30? Before I get to number 30, 22, I see that. Okay, 22. So let's go to number 22. And let's see, I'm going to scroll. And I heard something in the chat. Let's see. And 28, excellent. We'll do both of them. Here's 21. And here's 22. Perfect. Okay. So let's take a look here. It says, a standardized exam scores are normally distributed. In a recent year, the mean test score was 1477, and the standard deviation was 312. The test scores of 4 students selected at random are 1870, 1210, 2200, and 1360. And it says, find the z-scores that correspond to each value and determine whether or not any of those values are unusual. Okay, so guys, let me stop sharing this. I'm going to pull up my formula sheet because I believe it is here. Okay, here we go. So guys, this is how I'm going to convert my values to z-scores, okay? And then this is how I'm going to figure out if I have any unusual or very unusual scores. So this part on the right, and then here's my formula for the z stuff, okay? So let me come back to my notes. Okay, and we're going to do the first part right here. So remember, my formula is z equals x minus mu over sigma, okay? So my x value in this case, y'all, is 1870. So I'm going to take 1870 minus, I need to write 2 numbers over here off the side. It says our mean test score was 1477. So that's that number. Excuse me. And my standard deviation was 312. Okay. So I'm going to put 1477. I'm going to write this in parentheses, and I'm going to divide this by 312. Guys, what I'm going to do is I'm going to write out each of these 4 parts, and then I'll come back on my calculator and do each of the calculations, okay? So I'm going to do the same thing here, x minus mu over sigma. So my x in this case is 1210 minus 1477 over 312. I'm going to do this a third time, where my x is 2200 minus 1477 over 312. And then the 4th time we'll do this is going to be with 1360. Okay? So excellent questions, y'all. I'm glad y'all are asking these because I think these are really good questions. Okay, so I'm going to show you exactly how I'm going to do this on my calculator, and then we'll come back and answer the rest of it, okay? So let me stop sharing this. Let me come back to my calculator. Here it is. Okay, so the first numbers that I had were 1870. Let me turn this on, clear my screen. So I said parentheses 1870 minus 1477 divided by 312. And so I'm going to write this on back of my notes, guys, and then we'll come back and check this in a minute. And just to give you a heads up, the notes or the problem system are 2 decimal places. So to 2 decimal places, y'all, I'd be writing 1.26. Okay. So 1.26. Okay. Now I got to do 3 more of them. So the shortcut is, instead of me having to write this out every time, I'm going to go second entry. It just retypes it for me. And I'm going to change that 1870 to a 1210. Okay, and hit enter. And to 2 decimal places, I'm coming up with a negative 0.86. And I'll do this a third time. And I'm going to change that 1210 to a 2200. And I'm coming up with a 2.32. Again, I'm going to 2 decimal places here. And the last time I'm going to do this, I'm going to change that 2200 to a 1360. 1360. Enter. And to 2 decimal places, I'm coming up with a negative 0.38. Okay. So let me stop sharing that, the calculator part, and let me see. Let me come back to my review. Okay. So guys, if you notice, I wrote the answers here in red, and it said on every single time, round to 2 decimal places, right? So that's how we came up with each of those numbers. Okay. Now, it says which values, if any, are unusual. And it says select the choice below. If necessary, fill in the answer box with your choice. So we're either going to have unusual values or we're not going to have any unusual values, okay? So guys, what I'm going to do, I'm going to stop sharing this because I want to go back to my formula sheet, okay? So when I look at my formula sheet right here, okay, here we go. So if you look at the formula sheet, I said this is the part I was going to pay attention to. Remember when I have unusual scores? Unusual scores happen to be values between 2 and 3 or negative 2 and negative 3, okay? That's where I have my unusual values, or even, very unusual would be more than 3 or smaller than negative 3, okay? So I want to figure out, did I have any z values between 2 and 3 or negative 2 and 3? So when I come back to my review, and I look at this and we say, hey, you know what we did? We came up with a value here that was between 2 and 3. Now the question is, what was the value that got me that 2.32? Well, the value that gave me that 2.32 was when my x value happened to be 2200, right? Because that was the number that we had right there. So let me ask y'all a question. Now that we've gone through, and we'll do 28 because I think that was the next one. Now that we've done 22, do you guys feel better on like how to do a problem like 22? Anybody? Yeah?
Yes.
Good. Excellent. Perfect. Good. I'm glad. Okay. Excellent. Excellent. Good. Good deal, guys. Let me jump over to 28. Okay. Let me jump over to 28. And let's see if we can figure out number 28. Where are we? Here we go. Okay, perfect. Okay, so number 28 says, assume a member is selected at random from the population represented by the graph. Find the probability that the member selected at random is in the shaded area of the graph. Assume the variable x is normally distributed. Okay, perfect. So what we're trying to do here, y'all, let me get my pen going. Okay. We're looking for the probability that the number that we've selected is going to be between 200 and 375. Okay. So guys, the way we're going to do this is we're going to convert two values to z-scores. We have two values. We have one of them being 200, and we have the other one being 375. And we already know our mean, and we already know our standard deviation. So just like we did earlier, remember, this was my formula for converting an x value to a z-score. So the first time I do this, I'm going to take 200 minus 501 divided by 107, because that's my standard deviation, my mean. And I'm going to do this a second time with 375 minus 501 all over 107, okay? And so I'm going to just, guys, I'm just going to do this part on my calculator real quick. I think you guys already know how to do that part. I wrote it out for you. so that you can see the parentheses and everything. So 200 minus 501 divided by 107. Okay, so this value that I'm coming up with here, okay, there we go, is a negative 2.81. And then 375 minus 501 divided by, what do we say, 107 is, I'm coming up with a negative 1.18. Okay. All right. So guys, in essence, what we've done is we have converted these x values to z-scores. So instead of me finding this, what I'm going to find now is what's the probability that my z values are between negative 2.81 and negative 1.18. Okay. So guys, I have two ways of going about doing this. Okay. I can use my table or I can use my calculator. And I'm going to use my calculator for this problem, guys, because it's similar to the process that we've been doing before, okay? So let me show you what we're really talking about here. If you notice, they gave us a picture, right? And they gave us those two values. What we've done, in essence, is we've converted that table to the standard normal table, where the mean is 0, and then we have 1, 2, 3 deviations to the right, 1, 2, 3 deviations to the left. And the numbers that we came up with were negative 2.81, which is going to be somewhere over here closer to negative 3, and negative 1.18, which is just barely to the left of negative 1. And we're trying to find the area here. And if you notice, the way I've drawn this picture here, it looks pretty similar to that one. So the way I can do this on my calculator is I'm going to go second in bars. And we're going to look for something called the normal CDF, okay? Now, guys, the normal CDF, we're going to have two numbers. There's going to be a lower number and, oops, and there's going to be an upper number, okay? So my lower number was this value right here, which was at negative 2.81, and my upper number was this guy right here, which was the negative 1.18. So I'm going to show you again how I'm going to do this on my calculator. Let me stop sharing this, and let me come back to my calculator so we can see it. Where are we? We're right here. Okay. So let's turn this guy on. Let's clear everything. And let's see, we're going to go second vars. Normal CDF is the second one, y'all. Okay. So the two numbers that I came up with were a negative 2.81, what was it, 81? Yeah. Negative 2.81, comma, and the other one was a negative 1.18. And I'm going to close that off and hit enter. Okay, for these values, guys, we're normally going to 4 decimal places. So I'm going to put here 0.1165, okay? So 0.1165, so let me stop sharing this and come back to my review. Okay. And let's see, where are we? There we go, here's number 28. If you notice on the directions, y'all, it does say round to 4 decimal places. And we came up with 0.11, I already forgot, what was it, 65, something like that? Yeah, 0.1165. So let me write that here. And that, my friends, is how I do number 28, okay? So let's see, I heard something in the chat. Let's take a look. Is 27 somewhat similar? Give me 1 second and I will tell you. 27 is exactly the same. And guys, I'll tell you what, I sent out a problem. I'm going to take a look, a real quick look. I'm going to see if I can find it on my YouTube thing. So I sent out a problem. Oh, man. I sent one out to Let's see if I can find it real quick live. Let's take a look, see here, videos. Yes, so I had sent one like that. It might have been Wednesday last week, but I tell you what I'm going to do. I'm going to resend it today, guys, on both Prompt and Remind. And then in my other stats class, somebody asked me a question almost identical to 27. So I'm going to send both of them to y'all. Give me 1 second, and I'm going to send them to y'all right now. So let me copy this, and let me send this out. Okay. This is similar to 27 on the PDF. Okay. And let me copy everything, and I will send it over to them again. Okay, and I got one more for you all. Let's see. Okay. Okay, so guys, I just sent you all two links. I sent them both on Prompt and Remind, and it's just exactly like number 27. Okay, and like I said, guys, number 27, it came from the homework, right? So the two problems that I sent out, I mean, I know they came from the review, but I got these problems from the homework. So the two problems that I sent out now on both Prompt and Remind are exactly like number 27. Okay. And if you guys still have questions, please let me know. I'll be more than happy to go over the same process with you guys, okay? Let's see. We're going to keep moving along a little bit so I can see if anybody else has any questions. Let's see. I know we had 30-something. Let me see. 31. Okay, so guys, before I get to 31, anybody have any questions before I hit number 31? Okay, so let's take a look at number 31, and what we're trying to do here is we're trying to find, it says, find the indicated z-scores shown in the graph, okay? Okay, so what we're doing here, I'm just gonna kind of zoom in a little bit so you can see what's happening. And I'll walk you through the process here again, y'all. Okay, so for number 31, what I'm trying to do is I'm trying to figure out what would this z value have to be and what would that z value have to be, okay? So just to give you a heads up, guys, anytime I'm dealing with my normal curve, okay, the area under the entire curve is always equal to 1, okay? So the area is always equal to 1. That means that the area on this side is half and the area on that side is half, okay? So I know that the entire area on this side here is 0.5. I might say, you know what? How might I find this piece here in the green? How would I find that area? If I know the whole thing is 0.5, then how much would this piece right here be? And I would say, well, look, why don't I take 0.5 minus a 0.4783? Okay, so I'm going to do that here in my calculator, 0.5 minus 0.4783. And that would tell me that this area in green is going to be 0.0217. Okay, and you might be asking, well, why do you want to know that? Why is it that you're interested in that information? Because whether I'm using my table or whether I'm going to use my calculator, they both tell me the area to the left, okay? They're always going to tell me the area to the left. And I didn't know the area to the left. I didn't know this green portion here, so that's only had to figure that out. Okay, so I'm going to walk you through the process and how I can do this on my calculator. So in my calculator, guys, I'm going to go second and bars again. And I'm going to look for something that's called inverse norm. And then what I'm going to enter in here is going to be my area to the left. Okay. So here I would put inverse norm, and then my area to the left, we came up with 0.0217. Okay. So let me show you how I'm going to do this on my calculator. Let me stop sharing this. And let's go to our calculator. This is an excellent question. I'm glad it was asked. Okay, here we go. So I'm going to go second and then vars. And it's right here. It's number 3, inverse norm, right? And we said the area to the left was a 0.02 something or other. 17, right? 17. Here we go. 17. Okay. And that's telling me the z-value. So the z-value on that left side is going to be a negative 2.02. Okay, because I have to go to 2 decimal places. So negative 2.02. So let me stop sharing this. And let me come back over here. Okay. All right. And if you notice here, guys, the directions say use a comma to separate the answers. Okay. So we came up with a negative 2.02. This one here is just going to be positive 2.02. Okay. Now, I showed you how to do this using your calculator. And if you can see, for a lot of these problems, it gives me this big old table. And so some people might say, well, you know, suppose I wanted to use a table. How would I do this? And I told you that both your calculator and the table, guys, are always going to tell me how to, you know, my area to the left is going to be. So remember what we said our area to the left was? We said the area to the left was a 0.0217. So if I was going to use my table, what I would have to do is I would have to look at this table, and this is the number that I'm trying to find. I'm trying to find 0.2017. 0.2017. Let's see. Here it is. It's like trying to find a needle in a haystack, right? Trying to find something really, really difficult to find, right? And so look, here's negative 2.02. So negative 2.02, right? That's how I was able to find it. So again, you have options. Do you want to use your table? You can. You just got to look at a whole bunch of numbers and try to find the one that's going to match up. You know what I mean? And if you don't want to use your table, then you're going to use your calculator and you're going to go with the inverse one. So it's really entirely up to you on how you want to do this. You know, you have some choices. Personally, I'm using my calculator a whole lot, but I will say that the very first time I class, guys, I used the table a lot because I had, when I was teaching the class, it was a night class. I may have told this before, and I had a lot of like students that had not just graduated high school, right? I had students in their 30s and their 40s and stuff like that, and they found the table to be easier for them to use. So, you know, in that particular class, I was using the table a lot because it was something that that a lot of people were accustomed to. There's no right way or wrong way, right? They're both going to give you the same answer. The best way is whichever way works better for you. So if there's a certain way that works better for you than another way, then that's what I want you to use. So if using the table is easier, by all means, guys, use the table, right? And if using the calculator is easier for you, by all means, use the calculator, right? You're gonna end up with the same answer, okay? You're not gonna get anything different. You should come up with the same thing. All right, so let's see. That was number 31. So Jocelyn, thank you so much for asking that question. I think it was a really good question. Guys, do y'all have any other questions? Is there a question that you want me to do using the table in another type of problem? I just want to make sure that you guys feel okay, that you guys tomorrow when you come in and you sign into Blackboard to take your test, you're like, papas, you know what I mean? Like you feel like this is going to be easy breezy cover girl as opposed to really, really difficult. Can we try one, please? Yes. Let me see. Let me take a look at my problems here, and I'm going to see if I can find one using my table here. Let's see. 29 is just like 31. I'm trying to see if I can find one, maybe one of these here. Okay, so let me find, I'm going to try to find one. Okay, I'll tell you what, I'm going to do this one right here. So guys, I'm going to show you how I can do this problem using my table. Okay, this is number 19. Okay, and I'm going to show you this problem. I'm going to show you both ways. I'm going to show you with the calculator, and I'm going to show you with my table. So I want you to notice what it is I'm trying to find here. Here, I'm actually looking for the area, okay? Because I'm looking for the area. This is when I'm going to use my normal CDF, okay? And guys, I told you that we're going to have two numbers. We're going to have a lower number, and we're going to have an upper number, okay? So this is what we call our z-axis because we're using the variable z. Okay, we usually use x, but here we're using z. And if I were to think about this, just like an x-axis, right? If I go along to the right, my numbers get bigger and bigger and bigger, right? So if I keep moving forever, eventually I'm going to approach the concept of infinity if I move to the right. And if I move to the left, I'm going to approach the concept of negative infinity, okay? So since I'm trying to find the area in the shaded part of the curve, I already know where my lower value is. My lower value says, hey, you know what? We're going to start at 0.79. And because this graph, I know they kind of cut it off here, but the idea is this graph keeps moving to the right forever and ever and ever. And because I can't actually use the number infinity, what I'm going to do is I'm going to use the number 9999, okay? And I'm going to do this right here on my calculator, and I'm going to show you that whether I use my calculator or whether I use my table, I'm going to get the same answer, okay? So let me stop sharing this, and let me come back to my calculator. There we go. And so we said, let me turn this on so you can see it and clear my screen. So I'm going to go second vars. I'm going to go to my normal CDF, and we were starting at 0.79. And we were going to go all the way to 99999. Okay, so 99999. Okay, close it off, hit enter. And so the area that I'm coming up with, and guys, I'm always going to go to 4 decimal places. I'm coming up with 0.2148. Okay, so 0.2148. So we stop sharing this and come back to my notes. Okay. So the answer we came up with was 0.2148. All right. Now, guys, I told you before, anytime I'm using my table is always going to give me the area to the left. Okay. So the first thing I'm going to do is I'm going to look for the z value of a 0.79. So here's 0.7. Here is 0.09. So those two are going to meet up right there. Okay. So what that's telling me is that this area that I'll use in green, so you can kind of see what I'm referring to. That's telling me that that area right over there is going to be 0.7852. Okay. That's what the area in green would be. But the problem was really asking me to find the area in blue. So remember, the area, the total area, guys, is always equal to 1. So if I wanted to find this area here, I would say, let's take 1 minus 0.7852. And all we would do is come up with 0.2148. And that would be exactly how I would do that using my table, right? Using my table. So guys, when I'm doing this using my table, this is always going to be my process, right? My process is always going to tell me, hey, you know what? If I'm using the table, I don't ever want to forget it. It's always going to tell me that area to the left every single time, right? So if I want to find the area to the right, I have to do a little bit of work to get there, okay? And if I don't want to use my table and I want to use my calculator, then my approach is going to be let me use my normal CDF, and don't forget that I have lower and upper numbers, right? And looking at the picture will tell me, hey, this is the lower number, or this is the upper number. And I'm always reading my graph, y'all, from the left to the right, just like I'm descending. I'm always reading it from the left to the right. So let's see. What do you guys think? Are you guys feeling? Are you feeling better than what we did maybe than before 7:30? Anybody feeling? Yes. Yeah. Guys, ask me if y'all have any other questions. Please let me know. This is why I'm here. If you feel like you're okay, you can sign off whenever you're ready. If nobody else has any other questions, then we can go ahead and wrap things up. But if you do have a question, please let me know. This is why I'm here. Okay. Anything? You're all good? Awesome. Okay, so guys, let me do one more thing real quick. Let me stop sharing this. And oops. And just one last time, y'all. Let me see. Chrome tab. Here we go. All right. So yes, you guys can see this now. So again, guys, right here under the announcements, on the last announcement that I sent it earlier today. Here's going to be your formula sheet. Here's going to be the tables. The tables, guys, you don't actually have to download them, because if you notice, in those problems where you have tables, it has a little link so you can get to the tables, okay? But I mean, if you want to download them, you're more than welcome to. I'm just saying you don't necessarily need to. But your formula sheet is here, so make sure that you do save that formula sheet. Open it up, keep it as a PDF. You don't necessarily have to print anything unless you want to. And then the sign-up sheet, guys. So make sure that if you haven't yet signed up, go ahead and sign up. I didn't erase the names from the last time. I just didn't do it. So if you still signed up for the 10 a.m., excuse me, your name is there. If you had originally signed up for the 6:30 slot for last Wednesday, your name is there. But just wanted to give you a heads up on that. And then tomorrow, guys, there'll be 2 links on our Blackboard page at the very top. And it will say, test 1 or test 2 session 1 at 10 a.m. and test 2 session 2 at 6:30 p.m. You'll just click on that. And again, guys, we'll be on Microsoft Teams, just like Zoom. It's just a way of me being able to monitor you guys. The college is asking us to do this. But again, guys, you can use a formula sheet. You can use your calculator. So you're going to have a lot of resources, okay? And 15 questions, guys. I'm trying to keep it short and sweet, hitting the main points. I want y'all to really do well in this class. I want y'all to, get A's, B's, and hey, if you get a C, that just means you pass, right? And that's sometimes that's good enough. I have a friend of mine. She's a doctor, and when she was in medical school, she would always say, "Hey, you know what a C means? What? C means MD, right? Because I'm going to be a medical doctor, even if I get a C." I don't go to her, by the way. But anyway, I just, I hope you guys are doing well. If you got any questions, please let me know. And thank you guys for showing up tonight. I really do appreciate it. I'm glad you guys are doing well. And if you don't have any other questions, y'all, we will go ahead and wrap things up and sign off. So I'm going to stop.